So limit to infinity. So up to now we talk about the limit, so that numbers maybe focus on one given point, such as we just make a limit maybe x equal to 3 of fx, and then let's say that's the given line here, maybe somewhat like this, 1 2 3. We always look at the limit from the left side and then right side, and we determined it, right? Now one question. So using this graph here, what if I'm asking you limit x goes to infinity? So then we need to understand what this means here. Okay, so basically x move to infinity, which means x value moving forever. So before, if we are focusing on one particular x value here, now this time this x value going to infinity was going this direction to infinity basically. So you know what I'm talking about, right? Okay, therefore in this case, in this particular case, because the line keep on moving up somehow and moving down here, so it goes to just infinity here. Okay, then now another graph. What about, so we have y equal to 3, then 1 2 3 here, so that should be line here. Okay, then what about the limit x move to infinity of y? Then this must be 3 here. Okay, the reason is no matter what x value we choose, the corresponding x is always 3 here. Based on that fact, we can make limit x move to infinity, any constant value is always called constant value basically. Okay, and then like this, the limit x move to infinity, any polynomial function, I want to say that infinity. Sometimes it's going to both a positive infinity or both a negative infinity, but one thing we can say is always infinity here. Okay, then one interesting point here. What if we have graph looks like this? Oops. Something like that. Okay. So unfortunately, this one case we cannot define limit because it is not continuous. However, we can determine one-sided limit basically. Okay. Now I'm asking limit x move to positive infinite side, then I'm going to say this is gx. Then gx become, now this line approach to x-axis, but it never cross. We know that, right? Because the x-axis become our horizontal asymptote. So this become 0 basically. Now even limit x move to infinity from negative side here, then we're looking at this one, then it keeps on going this direction, but it never across the x-axis again. So they also become 0 here. Okay, so now, so this particular function we always define gx equal to 1 over x graph. This one, now we can say limit x move to infinity plus of gx, that becomes 0. Also limit x move to negative side gx also equal to 0. another word, the limit x move to infinity, 1 over x is always become 0. Okay? Then what about maybe h x equal to 1 over x squared? That graph, we can draw it. Looks like this and this here. Okay. So of course, this one, it is not continuous function, so we cannot just say the limit exists at x equals 0, but just going the infinite side, then we can define as a one-sided limit. So limit x move to infinity from the positive of hx, they also become 0, and then limit h move to negative infinity of hx also equal to 0. Therefore, now we can define limit x move to infinity, 1 over x squared also equal to 0 basically. Okay, before we confirm that, limit x move to infinity, 1 over x equal to 0. Now we just practice x move to infinity, 1 over x squared also equal to 0. So based on this fact, can you guess what about the limit x move to infinity, 1 over x to the n power? Yes, they also equal to 0. Okay, so that's the one of the key points we can analyze limit of infinity. Okay, and then another one. So what about the y equal to e to the x? Okay, y equal to e to the x, we know that this graph become either this one, this is the e to the x graph here. So this one case also, limit x move to infinity from the positive side, then it become positive infinity. But if you just make x go to negative side e to the x, then this become 0 here. So you know what I'm talking about, right? Because positive side going up forever like this, but negative side close to 0 basically. Okay, makes sense? Alright, then okay, so let's look at this graph here. So I just make fx equal to 3x minus 5 over x plus 4. So that's the given graph here. Okay, so obviously when you look at this carefully, it is not actually equal to 0 this case. So let's say we have find the limit fx goes to infinity. Then of course we are finding positive side and negative side as well. So what I want to do, I'm gonna just making only y value, but it doesn't work. So okay, let me just zoom in more. Okay, sorry about this, but anyway, obviously it is not equal to 0 here, right? I mean, yeah, 0 here. Then how can we define this case infinite limit here? This case fx. Can you guess? Okay, so this case it becomes 3 is the infinite limit. So I'm gonna just make y equal to 3 line here. Oops. As you see, so these two graphs approach to y equal to 3 line here, but it never across that. So this one case, limit infinite limit become 3 basically. Okay, so I'm gonna go to whiteboard and then explain how can we define why this case limit become 3. So the given function was, so fx equal to 3x plus 4, plus 4 or minus 4? Minus 5 over x plus 4, and then we confirm that limit x move to infinity of fx equal to basically 3. Then we want to find out how we can confirm this. Okay, so first of all, we want to find out highest degree of x term and divide by everything there. Okay, then limit x goes to infinity. Now, what is the highest x term? Yeah, just the x, right? So divide by everything. So 3x over x minus 5 over x over x over x plus 4 over x. Then this become limit x move to infinity. Now simplify, then 3 minus 5 over x over 1 plus 4 over x. Okay, then you know that those will be 0 because the limit 1 over x was equal to 0, which means limit x move to infinity 5 over x means 5 times limit x move to infinity 1 over x. So that should be also 0 then. Okay, then now the leftover is this one. So limit x move to infinity 3 over 1, so become 3 basically. Okay, then what can we confirm here? So if the degree value are exactly same, then the limit value become the leading term's coefficient. That will be the answer. Therefore, I can summarize one thing here. If limit x move to infinity, fx is given, and then fx defined fx over gx, I'm gonna say this become maybe axm plus a prime xm minus 1 plus blah 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 over bxn plus b prime xn minus 1, like this. And here, if the m is less than n, which means the denominator degree is bigger than numerators, then limit x move to infinity, fx must be equal to 0 because it turns into number time 1 over x to n power term. But if m is equal to n, then limit x move to infinity of fx, there will be their leading coefficient, which means in this case a over b. So a over b must be the answer for this problem. Okay, then let me give you one example. What if given gx equal to 3x fourth minus 5x cubed plus 2x minus 1 over now 4x fifth plus 6x 2 plus 5 here. Can you guess the limit x move to infinity of gx? If you think the answer becomes 0, then it is correct. The reason is when you compare the leading power between the numerator expression and denominators, the numerator degree becomes 4, denominator 5. Of course, 5 is bigger than 4, which means denominator degree is higher than numerators. In this case, the limit value always equal to 0. Okay, what about, I'm going to give you similar questions, but I'm making their powers are same now. Now the bottom part, I'm going to only switch 4x fourth plus 6x squared plus 5 like that. Then limit x move to infinity of hx, because the powers are exactly same, so the answer become 3 over 4. Okay?